The next lecture is 802.11ax key technologies. We start with multi-user defined. 802.11ax applies MU to multiple technologies. MU means that there are simultaneous transmissions between an access point and multiple Wi-Fi clients that depends on the supported technology. The use of multi-user orthogonal frequency division multiple access and multi-user multiple input multiple output technologies are defined by 802.11ax. 802.11ax has the most important new capability named as orthogonal frequency division multiple access that simultaneously serves the multiple users with varying bandwidth. 802.11ax radios also support OFDM for backward compatibility. In OFDMA, a Wi-Fi channel is subdivided into smaller frequency allocations known as resource units that will enable an access point so that communication can be synchronized with multiple individual clients assigned to specific RUs. There can be a simultaneous transmission of small frames to multiple users in parallel as shown in the figure. The excessive overhead at the medium access control sublayer has been cut down due to the simultaneous transmission. The whole channel has been allocated by the AP to a single user, or it has been partitioned to simultaneously serve the multiple users on the basis of needs of client traffic. OFDMA results in better frequency reuse, reduced latency, and increased efficiency. Subcarriers. In OFDM, a channel is divided into subcarriers through an inverse fast Fourier transform. There is an orthogonal spacing between the subcarriers so that they do not interfere with each other despite the lack of guard bands between them. Due to this, signal nulls are created in the adjacent subcarrier frequencies, due to which intercarrier interference can be prevented. 64 312.5 kHz subcarriers are consisted in the 20 MHz 802.11n or AC OFDM channel. A longer OFDM symbol time is introduced in 802.11ax of length 12.8 microseconds, which is 4 times the legacy symbol time of 3.2 microseconds. There is a decrease in the size and spacing of the subcarriers from 312.5 kHz to 78.125 kHz due to the longer symbol time as shown in the figure. The better equalization and enhanced channel robustness is allowed due to the narrower subcarrier spacing. A total of 256 subcarriers are consisted in an OFDMA 20 MHz channel because of the 78.125 kHz spacing. Subcarriers are of three types for 802.11ax, that is data subcarriers, pilot subcarriers, unused subcarriers. Next is resource units. When an AP of 802.11n or AC transmits on an OFDM channel to 802.11n or AC clients, each independent downlink transmission uses the entire frequency space of the channel. Each independent transmission uses all subcarriers when using a 20 MHz OFDM channel. The entire 20 MHz OFDM channel is needed for the client transmission to the AP. Total of 256 subcarriers are consisted in an OFDMA channel as shown in the figure. There is a grouping of these subcarriers into smaller subchannels known as resource units. 26, 52, 106 and 242 subcarrier RUs are designated to an 802.11ax AP when 20 MHz, 8 MHz and 20 MHz channel is subdivided, which roughly equates to 2 MHz, 4 MHz, 8 MHz and 20 MHz channels respectively. The 802.11ax AP dictates the number of RUs used within a 20 MHz channel and use different combinations. The whole channel may be allocated by AP to only one client at a time, or multiple clients are served simultaneously by partitioning the channel. Resource units and wide channels. So this table shows you the various resource units and wide channels. In addition to 20 MHz channels, 40, 80 and even 160 MHz channels can also be partitioned into various combinations of RUs as shown in this table. For example, if an 80 MHz channel was subdivided using strictly 26 subcarrier RUs, 37 802.11ax clients could theoretically communicate simultaneously using their OFDMA capabilities. Most real-world 802.11ax deployments will likely use 20 MHz channels with a maximum of 9 clients participating in multi-user OFDMA transmissions per transmission opportunity. The whole point of OFDMA is to make use of smaller subchannels. Downlink can be transmitted by 802.11ax APs to multiple 802.11ax clients, as well as simultaneous uplink transmissions are synchronized from multiple 802.11ax clients. The necessary frame exchanges are brought by using the trigger frames in both cases for multi-user communications. The query of 802.11ax clients about buffered data and the quality of service is performed using trigger frames. 802.11ax clients respond with buffer status reports so that the AP can be assisted to allocate RUSs for synchronized uplink transmissions. So this is all in this lecture. Thanks.